I'm not a believer myself, but there's little doubt that many mathematicians from the time of Descartes had strong religious convictions.
Maybe it's just a coincidence, but perhaps it's because mathematics and religion are both building ideas upon an undisputed set of axioms. 1 + 1 = 2. God exists. I think I know which set of axioms I'd put my faith in.
In the 17th century, there was a Parisian monk who went to the same school as Descartes. He loved mathematics as much as he loved God. Indeed, he saw maths and science as evidence of the existence of God. Marin Mersenne was a first-class mathematician. One of his discoveries in prime numbers is still named after him. But he is also celebrated for his correspondence.
From his monastery in Paris, Mersenne acted like some kind of 17th century internet hub, receiving ideas and then sending them on. It's not so different now. We sit like mathematical monks thinking about our ideas, then sending a message to a colleague and hoping for some reply.
There was a spirit of mathematical communication in 17th century Europe which had not been seen since the Greeks. Mersenne urged people to read Descartes' new work on geometry. He also did something just as important. He publicised some new findings on the properties of numbers by an unknown amateur who would end up rivaling Descartes as the greatest mathematician of his time, Pierre de Fermat. Here in Beaumont-de-Lomagne, near Toulouse, residents and visitors have come out to celebrate the life and work of the village's most famous son. But I'm not too sure what these gladiators are doing here. And the appearance of this camel came as a bit of a surprise too. The man himself would have hardly approved of the ideas of using fun and games to advance an interest in mathematics. Unlike the aristocratic Descartes, Fermat wouldn't have considered it worthless or common to create a festival of mathematics.
Maths in action, that one. It's beautiful. Really nice, yeah.
Fermat's greatest contribution to mathematics was to virtually invent modern number theory. He devised a wide range of conjectures and theorems about numbers, including his famous last theorem, the proof of which would puzzle mathematicians for over 350 years. But it's little help to me now.
Getting it apart is the easy bit. It's putting it together, isn't it, that's the difficult bit. Okay, how many bits have I got? I got 6 bits. I think what I need to do is put some symmetry into this. I'm afraid he's going to tell me how to do it, and I don't want to see. I hate being told how to do a problem. I'm not going to look. Then he's laughing at me now, because I can't do it. That's very unfair. There we go. Can I put them together? J'arrive! Got it! Now that's the buzz of doing mathematics, when the thing clicks together and suddenly you see the right answer.
Remarkably, Fermat only tackled mathematics in his spare time. By day, he was a magistrate. Battling with mathematical problems was his hobby and his passion.
The wonderful thing about mathematics is that you can do it anywhere. You don't have to have a laboratory. You don't even really need a library. Fermat used to do much of his work while sitting at the kitchen table, or praying in his local church, or up here on his roof.
He may have looked like an amateur, but he took his mathematics very seriously indeed. Fermat managed to find several new patterns in numbers that had defeated mathematicians for centuries.
One of my favourite theorems of Fermat is all to do with prime numbers. If you've got a prime number, which when you divide it by 4 leaves remainder 1, then Fermat showed that you could always rewrite this number as 2 square numbers added together. For example, I've got 13 cloves of garlic here, a prime number which has remainder 1 when I divide it by 4. Fermat proved you could rewrite this number as 2 square numbers added together. So 13 can be rewritten as 3 squared plus 2 squared, or 4 plus 9. The amazing thing is that Fermat proved this will work however big the prime number is. Provided it has remainder 1 on division by 4, you can always rewrite that number as 2 square numbers added together.
God! What I love about this sort of day is the playfulness of mathematics. And Fermat certainly enjoyed playing around with numbers. He loved looking for patterns in numbers. And then the puzzle side of mathematics. He wanted to prove that these patterns would be there forever.
But as well as being the basis for fun and games in the years to come, Fermat's mathematics would have some very serious applications. One of his theorems, his little theorem, is the basis of the codes that protect our credit cards on the internet. Technology we now rely on today all comes from the scribblings of a 17th century mathematician. But the usefulness of Fermat's mathematics is nothing compared to that of our next great mathematician. And he comes not from France at all, but from its great rival. In the 17th century, Britain was emerging as a world power. Its expansion and ambitions required new methods of measurement and computation, and that gave a great boost to mathematics. The university towns of Oxford and Cambridge were churning out mathematicians who were in great demand, and the greatest of them was Isaac Newton.
I'm here in Grantham, where Isaac Newton grew up, and they're very proud of him here. They have a wonderful statue to him. They've even got a shopping centre, the Isaac Newton Shopping Centre, with a nice Apple logo up there. There's a school where he went to, which has got a nice blue plaque, and there's a museum over here in the town hall, although actually one of the other famous residents here, Margaret Thatcher, has got as big a display as Isaac Newton. In fact, the Thatcher cups have sold out, and there's loads of Newton ones still left, so I thought I would support mathematics by buying a Newton cup.
And Newton's maths does need supporting.
Newton's obviously very famous around here. Do you know what he's famous for?
No. Discovering gravity.
Gravity.
Gravity, yes.
Gravity?
Apple tree and all that.
Yeah.
Gravity.
Gravity.
And that pretty much summed it up. If people know about Newton's work at all, it is his physics, his laws of gravity and motion, not his mathematics.
You're in a rush, okay. Acceleration, you see, one of Newton's laws.
"8 miles south of Grantham, in the village of Woolsthorpe, where Newton was born, I met up with someone who does share my passion for his mathematics.
This is the house.
Oh wow, beautiful.
Jackie Steddle is a Newton fan, and more than willing to show me around the house where Newton was brought up.
So here is the, well, you might call it the dining room. I'm sure they didn't call that, but the room where they ate, next to the kitchen, and of course there would have been a huge fire in there.
Yes, gosh, I wish it was there now.
His father was an illiterate farmer, but he died shortly before Newton was born. Otherwise, the young Isaac's fate might have been very different.
And here's his room.
Oh, lovely, wow.
As we think.
Oh, they preserved it really nicely. It's got
Yes.
a real feel of going back in time.
It does, yes.
I can see he's as scruffy as I am. Look at the state of that bed. That's how I think I left my bed this morning.
Newton hated his stepfather, but it was this man who ensured he became a mathematician rather than a sheep farmer.
I don't think he was particularly remarkable as a child.
Okay, so there's hope for all those kids out
Yes,
there.
yes. I think he had a sort of average school report. He had very few close friends. I don't feel he's someone I particularly would have wanted to meet. But I do love his mathematics. It's wonderful.
Newton came back to Lincolnshire from Cambridge during the Great Plague of 1665, when he was just 22 years old. In 2 miraculous years here, he developed a new theory of light, discovered gravitation, and scribbled out a revolutionary approach to maths, the calculus. It works like this.
I'm going to accelerate this car from 0 to 60 as quickly as I can. Now, the speedometer is showing me that the speed's changing all the time, but this is only an average speed. How can I tell precisely what my speed is at any particular instant? Well, here's how.
As the car races along the road, we can draw a graph above the road, where the height above each point on the road records how long it took the car to get to that point. I can calculate the average speed between 2 points A and B on my journey by recording the distance travelled and dividing by the time it took to get between these 2 points. But what about the precise speed at the first point A. If I move point B closer and closer to the first point, I take a smaller and smaller window of time, and the speed gets closer and closer to the true value. But eventually, it looks like I have to calculate 0 divided by 0. The calculus allows us to make sense of this calculation. It enables us to work out the exact speed and also the precise distance travelled at any moment in time.